Hello and welcome to another live stream of the Conquering FreeCodeCamp Curriculum Challenge. In this one, we're going to go over the debugging section inside the JavaScript algorithms and data structures certification. Oh boy, so many words. Alright, so we solved basic JavaScript, ES6, regular expressions, and then next one is debugging. This is a short one. Let's see how this goes. Introducing to Debugging Challenge. Debugging is a valuable and, unfortunately, necessary tool for programmers. It follows the testing phase of checking if your code works as intended and discovering it does not. Debugging is the process of finding exactly what isn't working and fixing it. After spending time creating a brilliant block of code, is it tough realizing it may have errors? These issues generally come in three forms. We have syntax errors that prevent the program from running, runtime errors when code fails to execute or has unexpected behavior, or 3. Semantic or logical errors, when code doesn't do what it's meant to. Alright, let's see. Modern code editors and experience can help identify syntax errors. Semantic and runtime errors are harder to find. They may cause your program to crash, make it run forever, or give incorrect output. Think of debugging as trying to understand why your code is behaving the way it is. Example of a syntax error, often detected by the code editor. Okay, so you can see here we have the function which is misspelled, so this won't work. Then here's an error of a runtime error. Okay, so we have an infinite loop, which is also not good. We need the condition to break out of the while loop. And example of a semantic error, often detected after testing code output. Let's see. Calculate array of rect. It should be multiplied, not added. Okay. Debugging is frustrating, but it helps to develop and follow a step-by-step approach to review your code. This means checking the intermediate values and types of values to see if they are what they should be. You can start with a simple process of elimination. For example, if function A works and returns what it's supposed to, then function B may have the issue. Or start checking values in the block of code from the middle to try to cut the search space in half. A problem in one spot indicates a bug in the first half of the code. If not, it's likely in the second. Okay. This section will cover a couple handful tools to find bugs, and some of the common forms they take. Fortunately, debugging is a learnable skill that just requires a little patience and practice to master. Alright, let's go to the first lesson. Use the JavaScript console to check the value of a variable. Both Chrome and Firefox have excellent JavaScript console, also known as DevTools, for debugging your JavaScript. You can find developer tools in your Chrome menu or web console in Firefox menu. If you're using a different browser or mobile phone, we strongly recommend switching to the desktop Firefox or Chrome. The console.log method, which prints the output of what's within its parentheses to the console, will likely be the most helpful debugging tool. This is also the one I'm using the most, so yeah, I can approve that it's very useful. Okay, placing it in a strategic point in your code can show you the intermediate values of variables. It's a good practice to have an idea of what the output should be before looking at what it is. Having checkpoints to see the status of your calculations throughout your code will help narrow down where the problem is. Here's an example to print hello world to the console. Well, so far we already used console.log a lot of times, so it's not that that of a mystery for us if you follow along. If you're just watching this recording and you have no idea, then yes, console.log will log everything that's inside with parentheses, so in this case a string, to the console. We have here a little copy of the JavaScript console, which is in Chrome and Firefox. So we can say console.log hello, and it will appear here underneath the 7, which is console here. Good. Use the console.log method to print the value of the variable a where noted in the code. Okay, add your code below this line. Console.log a. Alright, we can see the value of a now, which is 6. Understanding the difference between the freeCodeCamp and browser console. You may have noticed that some freeCodeCamp JavaScript challenges include their own console. This console behaves a little differently than the browser console you used in the last challenge. We haven't used the browser console. Oops. The following challenge is meant to highlight the main difference between the freeCodeCamp console and your browser console. When you run ordinary JavaScript, the browser's console will display your console.log statements the exact number of times you requested. The freeCodeCamp console will print your console.log statements for each test of that challenge, as well as one more time for any function calls that you have in your code. This is interesting. Hello Ankit, welcome to the live stream. I'm fine, how are you? I'm doing the 3rd live stream for today. It's too much for a day. Yeah, I have one more planned, but shh, don't tell anyone. Okay, this lends itself to some interesting behavior and might trip you up in the beginning, because a logged value that you expect to see only once may print out many more times. If you would like to see only your single output and not have to worry about running through the test cycles, you can use console.clear and check the browser's console. First, use console.clear to clear the browser console. After that, use console.log to log the output. Okay, let's see. Open your browser console. Get this to log once in your browser console and twice in the freeCodeCamp console. Alright, let's inspect. Okay, and look at that. Here we have the console. Whoa, so many errors. Stuff. Good. Let's zoom in so you can see. Use console.clear on the next line to clear the browser console. I did that with this button. Oops. Use console.log to print the output value. Console.log output. This goes once and once here too. I'm not sure why. Check the two consoles to see the difference. freeCodeCamp console should have printed the variable twice, once for each test of this challenge. Browser console should only print the variable once because it clears the first one. Well, it didn't. I'm not sure what they mean. Maybe they fixed this in the meantime. Alright. Ankit, why are you sad? Run the tests. Oh, you should use console.clear. Okay. Console.clear. Next. Use typeof to check the type of a variable. We learned about typeof before. So basically you can put typeof before any type of any data structure or variable or anything, and it will say inside of a string what type it is. JavaScript recognizes 6 primitive data types: boolean, null, undefined, number, string, and symbol, and one type for mutable items, object. Note that in JavaScript, arrays are technically a type of object. Look at this. So we have type of this and it's object. Ooh, so that may lead to a lot of errors. So keep that in mind. Add two console log statements to check the type of each of the two variables, 7 and 3. Okay. Type console.log type of 7 and console.log type of 3 is a number and is a string. You can see there the concatenation because one is a string, so they concatenate instead of adding. Okay. Next. Catch misspelled variables and function names. The console log and type of methods are the two primary ways to check intermediate values and types of program output. Now it's time to get into the common forms that bugs take. One syntax level issue that fast typers can commiserate with is the humble spelling error. Transposed, missing, or miscapitalized characters in a variable or function name will have the browser looking for an object that doesn't exist, and complain in the form of a reference error. JavaScript variable and function names are case sensitive. Fix the two spelling errors in the code so the net working capital calculation works. Alright, let's see. We have two errors, receivables, and this is receivables. Alright. Like that. And payables is payable here. Alright. Run the test. Good. So we fixed it. Hello Neo, you'll do this tonight. Perfect. Alright. Catch and close parentheses, brackets, braces, and quotes. Another syntax error to be aware of is that all opening parentheses, brackets, curly braces, and quotes have a closing pair. Keep that in mind. And I also would add the back quotes for the template strings. Forgetting a piece tends to happen when you're editing existing code and inserting items with one of the pair types. Also, take care when nesting code blocks into others, such as adding a callback function as an argument to a method. One way to avoid this mistake is as soon as the opening character is typed, immediately include the closing match. Then move the cursor back between them and continue coding. Fortunately, most modern code editors generate the second half of the pair automatically. So you can see here, if we type a parenthesis, we have the enclosing one, and also our cursor goes inside. This goes for all of the brackets, for the quotes, and for the backticks, which is nice. Most of the modern code editors do this, so you don't have to worry. But in case they don't, you'll have something like this. Then just add another one and go back like this, so you make sure that it works. Fix the two pair errors in the code. Okay, so with this misses a ending bracket, and here we're missing an ending parenthesis for the parameters. Okay, catch mixed usage of single and double quotes. Alright. We learned about this in the past, so we need to make sure that when we have quotes inside a string, maybe use the other type of quotes outside of it to wrap it. So in this case, you can see we have double quotes outside and single quotes inside. Or also you can escape it. So you can escape it with the backslash character. Alright, let's fix this. We can fix it by changing this to a quote, single quote. Or the best would be to use backticks, which is the newer way to create strings. Oh, so they expect us to change these. Alright, let's. Your code should take the double quotes around the entire string. Oh well. So they don't like backticks. Alright. Halfway there. Catch use of assignment operator instead of equality operator. Yeah, let's see. I'm reading it faster, but you can take the time and read it on your own if you want. Okay. Yeah, so inside the condition of an if statement, make sure that you use triple equals always. I mean, that's my advice. I learned from some of the best, so I guess it's worth it. Next, catch missing open and closing parentheses after a function call. Okay, when a function doesn't take arguments, you may forget to include them. Oftentimes the result of a function call is saved in a variable for other use in your code. You can see here we have a function and we forgot to call it. So it will basically store this function in the result now. So we could do something like this to call the function on the result, but I guess we would want to do something like this. Oops. Alright. Catch arguments passed in the wrong order when calling a function. Okay. Yeah, make sure that you put the arguments in the right order. If the arguments are the same type, all integers for example, then the logic of the code won't make sense. Make sure to supply all required arguments in the proper order to avoid these issues. So you can see here we have exponent and the base, but the exponent right here, but we want it here, E and B, right? Oh, correct. So the base, your function raised to power raises a base to an exponent. Unfortunately, it's not called properly. Fix the code so that the value of power is expected 8. But it is 8. So what's wrong? Your code should use the correct order of the arguments for the raise to power function call. E and B. That's here. I guess they want us to change it here, base and exponent. Yeah, probably. Alright. Catch off by 1 errors when using indexes. Off by 1 errors, sometimes called OBOE, crop up when you're trying to target a specific index of a string or array, or when looping over the indexes of them. JavaScript indexes start at 0, not 1. Keep this in mind. Indexes start at 0, which means the last index is always 1 less than the length of the item. So if you remember, we did array.length minus 1 if you wanted to go take the last item. Okay, if you try to access an index equal to the length, the program may throw an index out of range reference error or print undefined. When you use string or array methods that take index ranges as arguments, it helps to read the documentation and understand if they are inclusive. The item at the given index is part of what's returned or not. Here's some example of off by 1 errors. Okay, loops 1 too many times at the end. You can see that we go up till the end and we don't want it. We want to go we don't want to include the length of the last one. I mean, it's more than the last one. So for example, if this has 26, we want to go up till 25 because we start from 0. Okay, loops 1 to few because we started from 1. And this godly lux approves. This is the right. So when you want to loop over an array, you start at 0 and you go up to the length. Or you can also say something like, let me show you here. So this should be 0 and you go up to the length. Or if you want an equal here, you can do len minus 1. But as a base approach should go like this. Use caution when pre-initializing variables inside the loop. Okay. Sometimes it's necessary to save information, increment counters or reset variables within a loop. A potential issue is when variables either should be reinitialized and aren't, or vice versa. This is particularly dangerous if you accidentally reset the variable being used for the terminal condition, causing an infinite loop. Yeah, so if you're changing one of the i's and j's here inside the loops, you might find that it will go on forever. Printing variables, Printing variable values with each cycle of your loop by using console.log can uncover buggy behaviors related to resetting or failing to reset a variable. Alright, let's see what we have here. The following function is supposed to create a two-dimensional array with m rows and n columns of zeros. Unfortunately, it's not producing the exact expected output because the row variable isn't being reinitialized. Set back to an empty array. In the outer loop, fix the code so it returns a correct 3x2 array of zeros, which looks like 3x2. Okay, creates a two-dimensional array, adds the mth row into the array, pushes n zeros into the current row to create the columns, pushes the current row, which now has n zeros in it, to the array. So I'm not sure what's wrong. New array, row push. So it's not expected up because the row variable isn't being reinitialized. Set back to an empty array. Oh, I see. So it's not set back to an empty. We can do this row array. Okay, and we have now the expected output. So it kept pushing inside the row. Alrighty, I think we have one more. Prevent infinite loops with a valid terminal condition. So you can see here we don't have any terminal condition. It just goes on forever and ever. So you always, when you create a while loop, I would suggest that you do the terminal condition first. So you do while, for example, you do while I is less than 5. And then right inside the while loop you say I++ or something. So you make sure that it will finalize sometime in the future. Let's see the bug here. The myFun function contains an infinite loop because the terminal condition I different than 4 will never evaluate to false. Look at that. We start with 1, increment 2, so it becomes 3, then increments 2 again, and it becomes 5, 7, and so on. So it will be it will be always different than 4. So it will still keep going. Usually in a for loop, you wouldn't say something like different than 4. You would say less than or greater than, depending on your condition. So that way, you make sure that you have an upper bound. Good. Fix the comparison operation in the terminal condition so the loop only runs for I less than or equal to 4. So this is easy, we just change it to less than or equals. Alright, look at that. We completed this one also, and it was pretty fast, 25 minutes. Thank you all for watching. If you have questions, let me know in the comments. And for those of you who are live, let me know in the live chat. Okay. Naima says that please suggest best practices tutorials for debugging. I think this one covered at least the big parts. Obviously, there are parts that you might want to look over. We have the debugger, we have breakpoints, all that, but apparently they don't go over. So, to be honest, I don't use those that much. I use what they taught us here most. So yeah. Alright. That's it for now. And we're going to meet again in the next live stream, which will be about basic data structures. Ooh, look at that. This will be fun. Thank you all for watching. I wish you a great day and happy coding. Bye.